Permutations. In this video, you will learn how to use the fundamental counting principle in specific problems in which the order of the objects in an arrangement matters. Before you work through this video, you will need to know the fundamental counting principle. If necessary, you should refer to the following video which covers this topic. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. An arrangement of a set of n objects in a specific order is called a permutation. The permutations consider the order in which objects are placed to be important. Let's see how it works. Three different runners, designated A, B, and C, are competing in a 100 meters race. How many different orders can runners finish the race? The fundamental counting principle can be used to determine the rank. Any of the three athletes can finish first, then any of the remaining two athletes can finish second, and finally one of them can finish third. So the number of possible ranks is 6, or 3 factorial. This is a typical permutation problem, since changing the order in which the athletes finished would create a new rank order. For permutations, the order matters. BCA is not the same as BAC. Permutations do not allow repetition. A and B is not a valid permutation of ABC. It does not make sense for the same athlete to make two rankings at the same time. Hence, a permutation represents counting without replacement repetition, in which order matters. The general formula to find the number of permutations of n objects taken r at a time, when the order in which the n objects is chosen matters, is given by the following formula. Let's see how it works. How many different ways can the letters of the word score be arranged? We must find the number of permutations of 5 letters taken 5 at a time. So n equals 5 and r equals 5. Let's perform the calculations. In a race road cycling event, 15 men competed. How many different ways could 3 of the athletes finish first, second, and third to win the gold, silver, and bronze medals? Since each winner will receive a different medal, the order is important. We must find the number of permutations of 15 things taken 3 at a time. So n equals 15 and r equals 3. How many different passwords can be made using 5 digits if a digit can appear only once? The total number of digits is 10. From this collection, we can choose 5 different digits and arrange them to make a password. Therefore, we are looking for the number of ways that we can order 5 objects from a set of 10 objects without repetition. This is exactly what the permutations formula is for. Replace n with 10 and r with 5 and perform the calculations. How many different ways can the letters of the word repeated be arranged? The word repeated has 8 letters, of which the letter E is repeated 3 times. But the 3 letters E are indistinguishable from one another. If the 8 letters were all distinguishable, there would be 8 factorial different permutations. However, the three letters E are indistinguishable, and there are 3 factorial indistinguishable ways of arranging them. So we need to divide the number of possible permutations of all the letters by 3 factorial. The number of distinguishable ways of arranging the letters of the word repeated is 8 factorial divided by 3 factorial. This is a particular example of the following general result. The number of permutations of an object of which one object is repeated q sub 1 times, another is repeated q sub 2 times, and so on is. Find the number of permutations of the letters in Mississippi. Mississippi has 11 letters, of which I is repeated 4 times, S is repeated 4 times, and P is repeated 2 times. So the number of distinguishable permutations is given by the formula. Combinations. Suppose that you wish to select 3 friends from a group of 5 friends to go on a trip with you. The number of permutations of 5 people taking 3 at a time is given by the formula. Replace n with 5 and r with 3. You should notice that it does not matter if you choose John, Mary, Richard, or Mary, John, and Richard, or John, Richard, and Mary, since you still end up with the same group going on the trip. Since any selection of 3 friends can be arranged in 3 factorial, or 6 different ways, each selection of 3 friends will appear 6 times in the set of possible permutations. Therefore, you need to divide the result by 3 factorial. This is an example of counting without repetition, where order does not matter. This is what mathematicians call a combination. The arrangements in which the order does not matter are called combinations. The number of combinations of our objects taken from a group of n distinct objects is given by the formula. A chess tournament is to be held where every player plays each of his opponents. Given that there are 10 participants, calculate the number of games that will be played. We would like to count the number of ways we can pair 10 players. This means that we are counting without repetition, and order does not matter, since player 1 versus player 2 will be the same as player 2 versus player 1. This means that we are counting the number of combinations of 2 players taken from the collection of 10 players. Hence, the total number will be given by the formula. Replace n with 10 and r with 2, and perform the calculations. A football team of 11 is to be chosen from 15 players. How many different teams can be selected? There are 15 players to choose from, so n equals 15. We are choosing 11 at a time, so r equals 11. Now perform the calculations. A committee of 5 is to be chosen from 8 men and 9 women. In how many ways can this be done if there are to be 2 men and 3 women on the committee? The number of ways of choosing the men is the number of ways of choosing the women is Note the first event is choosing men and the second event is choosing women. We now use the fundamental counting principle to find the total number of ways of choosing the committee.